Alright, so here we're going to be starting on section 4.2, part 1. And we're going to be dealing with logarithms. Okay, so the last two sections we dealt with exponentials, which are things like y equals 2 to the x. Okay. This is great if you're given an x, but what are you going to do if you're given a y and you need to solve for x? If you've been paying attention, you know to solve for x, we need an inverse. Okay, now the problem is that exponentials are transcendental. Means we can't go in and just get an algebraic inverse for these things. But what we do is we define an inverse, and the inverse of exponentials are logarithms. And that's what we're going to be dealing with here. Now, since logs are inverses, like anything else, we're going to be swapping x and y values. So let's take a look at how these things are related. And this will be the first type of thing we're going to be dealing with. So if we've got something, this is in exponential form. That's my base. This is my exponent. Or it's my old x value. And this is f of x or y. It's our answer. So to convert this then into logarithmic form, first thing we're going to have to do is write log. That's the first step. Okay, now you take your base, which in this case is 2, and you write the base down below log like that. Okay, now at this point, we deal like what we've been dealing with, where we're going to swap x and y. So we know that my old y value here is going to go in here, and my x value will go out there. And these are equivalent forms, but they're inverses. And again, you can see we swapped our x and y's, but we've got to be able to handle this base, and we do that right there. So let's deal with another one then. Let's say you are given not do 3. Two to the 5th equals 32. And I don't want to do 2 to the 5th. Let's do 4 cubed is 64. Okay, so this is exponential form. We want to write this in logarithmic form. So to do that, I start out with log. There's my base. So I put that down below log. Then I take my y value and my x value. And there we go. Okay, so let's see what happens then if we want to go the other way. I gave you logs and you want to write these in exponential form. Let's say I gave you log base 5 of 25 equals 2. I want you to write that in exponential form. So the first thing you do is you pick out your base. It's 5. Then you come up, there's your power. 5 squared equals 25. As you can see, we're just swapping these two values right here. Okay, let's work another example of this. Let's do log base 8 of 2 equals 1/3. And I want to write this in exponential form. So again, you pick out your base first. My base is 8. That is my exponent. 8 to the 1/3 equals 2, or the cube root of 8 equals 2. You should be able to recognize these as equivalent forms. Okay, so that's how we do this. To evaluate a logarithmic expression, first step, I would try to write it in exponential form. So let's take a look at some examples. For instance, log base 3 of 3. They want you to evaluate it. So you want to find out what it's equal to. Okay, well, let's write this in exponential form. So there's my base. 3 to the x equals 3. Well, you can take a look at this and tell that x equals 1. In other words, 3 to the x is going to equal to 3 to the 1, which means x is 1. You have the same basis. Let's take a look at another one. Or another way of looking at that is 3 to what power gives you 3? And the answer is 1. Let's say you've got log base 3 of 1. And you want to find out what power gets that to you. So you write it in exponential form. 3 to the x equals 1. X is 0. Anything to the 0 power is 1. Okay, so the last one let's look at before we move on here is log base 3 of 3 squared. So I'm going to go ahead and do this first. So I'm looking at log base 3 of 9, which means I want 3 to what power gives me 9, which means x is 2. And if you look at that, you'll notice that that is your exponent there. Okay. Following is really important. Know properties on page 343. Write in your notes. Okay. So with that said, log base 2 of x equals 5. Okay, well, how are we going to solve this guy? Let's write it in exponential form. 2 is the base, to the 5th equals x. You can do this, to the 5th is 32. Okay, these are also used in carbon dating. But before we go on, I want to make a couple of notes here. There are a couple of special logs. If you ever see anything written like that, log with no base, that means the common base, which is base 10. If you see something written ln, that means base e, or it's the natural log. Okay, so let's take a look at a couple of examples. Since exponentials are used in carbon dating, so are logs. Let's take a look at an example, carbon-14 dating. We're looking for the age of something. It's going to be equal to negative 8267. And these equations are derived from regression analysis. Natural log of d over d0, where a is your age, d is the amount of carbon-14 left, d0, or d the mass, is the mass of carbon-14 you started with. So here's what we know. We only have 73% of our original carbon-14 left. You notice this is ln, which is your natural log. Find the age. Okay, well, this 73% is your d over d0 times 100. So d over d0 is going to be equal to 0.73. And now you just plug this in. So we know that my age is going to be equal to negative 8267 times the natural log of 0.73. And when you plug this in your calculator, you end up with about 2,602 years. So there's the first part of logarithms.